All right, so let's pick up where we left off. So we just got done doing example 2 in section 6.1. So now the next part is looking at the order in the real numbers. Now order, it seems like a fancy word, but all they care about is which one's bigger than the than the other one. So we can do that using inequalities. So we have our greater than symbol, our less than, our greater than or equal to, and our less than or equal to symbols. So now just some examples. So 5 is greater than 2. We got 13 is less than 17. And we got negative 8 is greater than or equal to negative 10. Now, positive comparisons are fairly easy to do. People have a natural instinct to be able to do those easily. But when it comes to negatives, negatives always tend to throw people off. So you got to be a little bit careful with that. Now, one of the ways you can avoid mistakes is to use a number line. So a number line is a great way to kind of see exactly which one is bigger than the other. So since we know what a number line looks like, then we can use that to our advantage. So how we can rephrase things is to think of the greater than symbol as is to the right of, whereas the less than symbol would mean is to the left of. So that is a nice way to, like I said, to visually see it. So let's just try a few examples. And again, if you are above all this, then that's great, and you can do this with no problem, that's fine. But if you're a little rusty, if you're a little uncertain, the number line is just a helpful way to reinforce that you're doing it correctly. So negative 5 compared to positive 5. Well, we can quickly put those on a number line. Now we don't need to put in all the little dashes. All we need to make sure of is that we're putting them in the right spots relative to each other. So negative 5 should be on the left side someplace. So let's just put it right here. Positive 5 better be over here. So that's, we can kind of visually see that in our minds, what that number line looks like. So this is right. But now, is it to the left of? Is negative 5 to the left of positive 5? Sure it is. So this has got to be true. All right, let's try the next one. So we got negative 12 and negative 6. All right, so if we're plotting this on our number line, we're plotting these two spots. If we're working our way from right to left, and we're putting these numbers down, negative 6 would happen first, and then down the line would be negative 12. So that's what it should look like on your number line. So now let's answer the question. Is negative 12 to the right of negative 6? Nope. Negative 12 is on the left of negative 6. So this has got to be false. And we can do that with all of these problems. So negative 35, negative 42, so we got our two spots. So which one goes where? Negative 35 better be right over here on the right. Negative 42 better be over here on the left. And now, is negative 35 to the right of negative 42? You betcha. So that is, true. All right, let's do a couple more. So we got our two spots. So negative 212 and negative 188. All right, well, again, if we're working from right to left, which one do we hit first? We would hit the 188 first, and then we'd hit the negative 212. So now is negative 212 less than or equal to or to the left of negative 188? Yeah, it's on the left. So that's true also. Negative 73, I think, is going to be on the left. Negative 67 is going to be on the right. Is negative 73 to the right of negative 67? Nope. That's going to have to be false. And then this last one, 9 is greater than or equal to 9. Well, it's not greater than, but because of that line underneath, that makes it true. So this one is true because it's equal to, it's got to be true. So that's how we can do some comparisons using that number line. It's a nice way to look at it. All right, so the last part of this is looking at additive inverses and absolute value. So additive inverses are basically looking at opposites. So how would you get from one side of the zero to the other side exactly? And that's using additive inverses. So the additive inverse of 3, we know should be negative 3. Additive inverse of negative 2, well, that better be positive 2. Now within this, you could also analyze it a different way. You could say, okay, well, the additive inverse should be negative negative 2. But negative negative 2, maybe if I moved it up, you'd see it, should be 2. So the two negatives do cancel each other out to give you a positive 2. Now we're going to be careful though. We're going to see some cases where it's a little different. So let's jump to the last page here and scroll down some. Boink. All right, so we're at absolute value now. Now what is absolute value? Well, if we think of that number line as our basis, it's looking at the distance from 0 to the number. So first thing it says though is that the distance of additive inverses on the number line from 0 are equal. So if you went from 0 to one number and then 0 to the additive inverse, it's going to be the same distance. But in general, the definition would be the distance between 0 and the number is called the absolute value. So let's take a look at a few cases. So we got the absolute value of 6. So if we wanted to graph this, we'd have 0 and 6. And now, what's the distance between 0 and 6? Hopefully you're screaming at me, 6, 6. And you'd be right. So that is a quick problem. Absolute value of 6 is 6. Now, mathematicians are lazy. We don't like to write a lot of words if we don't have to. So if we can abbreviate stuff, that's what we're going to do. And that's what these vertical lines around the 6 mean. That means absolute value. So anytime you see this, it wants to know the distance between 0 and that number. So in this case, the answer is still 6. But what about this one? The absolute value of negative 7. So now, if we draw it again, 0, negative 7. How far apart are those? Now, hopefully you're not saying negative 7 because we're talking about distance. Distance better be positive. If you can travel a negative distance, then you got something special going on. So, no, it's going to have to be a positive 7 because it's distance. So this is 7. So now looking at all this, you're probably saying, okay, well, all absolute values are 7. Whoop-de-doo. Well, there's always little tricks that mathematicians can do, so we got to be careful. So, however, we must be careful about the location of the negative signs. So the negative signs are where we got to just look at it twice to make sure we're interpreting it correctly. So, if we looked at the first one, the negative of the absolute value of 5, it's not written the same way as this problem was. The negative is on the outside. Here, the negative was on the inside. So we can't treat them the same way. How you would simplify this is you almost just cover up the negative first and say, okay, well, wait a minute. What's the absolute value of 5? That's got to be positive 5. But because the negative is outside, we have to tack it on at the end. So the answer is negative 5. So we got to be careful. 7 minus 3, all absolute valued. Well, if we broke this down step by step, first thing we would do is do the subtraction. So we got the absolute value of 4, but the absolute value of 4 should be positive. So it's positive 4. What about this last one? Well, again, we want to be really careful. We got a couple of negatives in here. We got some subtraction going on. Let's break it down step by step. So now, if we keep the negative in front, the negative on the inside, 5 minus 2 better be 3. Now, we really don't need the parentheses, so let's just rewrite it real quick. So we got the negative of the absolute value of negative 3. Well, some of you are probably saying, well, wait a minute, can't we just cancel those out and it's going to be 3, right? Well, that is not right. It is not going to be equal to 3 because they don't cancel out when it's absolute value. We have to treat it the same way we did this problem over here. So if we cover up the negative and say, what's the absolute value of negative 3? The answer is 3. But because the negative is out front, we have to tack it on. So this answer is negative 3. It's not the same as when you're using parentheses. So they're two different animals. All right, so let's tackle this last question, and that will wrap up 6.1. So true or false? Now, in this case here, we do have parentheses. So because it is parentheses, we can simplify it to a positive. So now, is negative 8 greater than 2? I don't remember user number line. So we got negative 8, we got positive 2. Negative 8 is to the left, not to the right of 2. So this has got to be false. All right, so how about this one? If we simplify these both down, there's no negatives on the outside, so we really don't got to worry about it. So this should be 6 less than 9. And then we know that one's true. Don't even have to draw that one out. Okay, so this last one, negative is on the outside. So if it's on the outside, it's got to be negative. So negative 8. And then negative's on the inside. So now it's going to have to be positive. Well, very similar to the first one. So this one we can see is also false. All right, well, so hopefully that wasn't too terrible for you, but definitely go through the homework, make sure you understand it, and if you have questions, make sure you ask. So we'll stop the video here, and you can pick up the next section in the next video. See you very soon.